All right, welcome back. Been a while. It's the 30th, September 30th. So the assignment is right there. We're talking about bivariate data, which is Unit 2. Unit 1 was univariate data. So one variable, two variable, bivariate's two, like bicycle. So there's two ways you can display two ways you can display bivariate data. There's quantitative and categorical. I'll start with categorical because we won't really talk about it much this unit, but if you have two variables like gender and hair color, you can display it in a two-way table. So like the top corner is males with dark hair, the top right corner is like males with light hair, etc. And so you can do those, you can find a bunch of stuff with them, but we won't do that much. Our focus is on scatterplots. So you've all seen what scatterplots look like, and a scatterplot shows association between association or correlation, those are basically the same word, between two variables. Correlation does not imply causation, meaning just because two things show a good relationship, as one goes up, the other one goes up, or something like that, it doesn't mean that one caused the other one. So when you draw a scatterplot, tails. T stands for title, A is axis, meaning X is the explanatory or independent variable, Y is the response variable, which is like the dependent variable. I is for increments, show even increments. L is for labels. S is for scale. So labels obviously label your axes. Scale, make sure your scale just includes all of your data and it's reasonable. If your scale looks like this, where all your data's up top, you clearly have too much on the bottom and not enough on the top. That's a messed up scale, which goes with plus. Tails plus is, I should have wrote tails plus up there. But your data covers most of the graph is a plus. So if you don't have most of your graph covered by the data, then it's trouble. This side, describing scatter plots, I have to talk about three things. So this is not SOX. For bivariate data, you do different. It's direction, strength, form. So strength is strong or weak or some variant of it. So this is like no correlation. It's a disaster. No one can tell what it is. The R values we'll talk about in a second. Weak is like it's not perfectly in line, but it's at least going in a direction. As X goes up, Y is going up. Strong is perfectly in line or close to it. As X goes up, Y goes up. So you can tell like an R value of 1 is strong, an R value of 0 is weak, and an R value of like 0.6, 0.7, or R value of 0 is nothing. 0.6, 0.7 is pretty weak. Direction, positive and negative. Positive means as X is going up, Y is going up. Negative means as X is going up, Y goes down. You can say linear or nonlinear. Please use context. Tell me what X and Y are. And if you are talking about a nonlinear graph, just say some words about it. You can say it's nonlinear and then describe what's happening. Like, oh, it's going up higher at the later X's, or it started down and then it's going up, or something like that. The last thing on today's, this is a longer one, is the correlation coefficient. It's called the R value. You'll probably forget the name correlation coefficient before the end of the year, but R value tells us how strongly linear our data is. So it's basically just a number indicator of strong or weak. An R value of -1 is really strong, and it's negative, so it's in the negative direction, whereas an R value of 1 is also really strong, it's just in a positive direction. So if the ends are strong, the middle is weak. 0 is just a disaster. It's no correlation here, is it 0? This is an R value of -0.9, so it's not perfect, but it's pretty close. So it's kind of close to -1, and it's in the negative direction. This one's 0.7, so this one's like, it's a little bit weaker, going up, and you got an R value. We find it in the calculator, but we'll do that tomorrow. Have a good one, you guys. Comment on any questions or anything. See ya.